Hey everybody, thank you for clicking on my video. I really appreciate it. If you haven't subscribed and liked, please consider doing that now. So today, for those that are new, what I do on this channel is I take an old electronic project from an old electronic magazine, build it and bring it to life, and then demonstrate it. That's what I normally do. And this week is no exception. So I'm going back to Electronics International, Electronics Today International, the Canadian version. And I'm going to the, the February 1982. So that's 43 years ago. And I'm going to build a project, and it's called the Sound Bender. So just high level overview from what I understand is before this type of a device was made, you would mix two signals. So you would mix a voice or guitar and you'd put it into a device, and they'd call it a ring modulator. And then the other input would be a sine or a triangle wave. And you would mix the two together and it would give you a funky sound. So that's what I'm trying to build today. The Sound Bender will do all of that with a couple of chips, and you'll have just the one input because inside the XR2206 chip will be there, and that'll act kind of like as an oscillator, and then the output of that will be almost like a modulated signal, right? I'm curious to see what it's going to sound like, first of all, and I'll definitely scope it out after I get it built. So that's what we're going to do. Now, I'm just showing you right now the author's version of the device, and hopefully mine looks something like that. And I'm also now showing you the internal what it looks like inside the device. So let's maybe talk about the schematic. Okay, so I'm showing you the schematic now. And just to preface my understanding of the schematic, I just want to make sure that you know that I'm no genius, right? I'm a technician at the very most. I'm definitely not an engineer. So hopefully I get this right. And I've got a lot of it from the magazine, so I don't want to act like I'm smart or anything like that. But I understand what's going on, and that's the key point. So the input you could see on the left-hand side, and then it goes into that op amp. It's a 741. It's multiplied by 10, and then if you look at the output, pin 6 of the first IC, you'll see that it's tapped in two directions. One connection goes up, and then it bypasses the 2206, which is IC2 in the middle, and then it goes to the next or the third IC, which is the output amp. And also pin 6 in the beginning on IC1 goes into, I presume that's the input of the XR2206, not too sure. But anyway, you've got then controls for triangle and sine wave, and the XR2206, of course, is well-known function generator, audio frequency kind of device, and it's wonderful. I've got a couple of them, actually. Anyway, then the output finally gets amplified. Not amplified, sorry. It's divided by 10, right? So we want to get back to what the original signal was. So the first op amp multiplied by 10, and then the second one will divide by 10. So we should have the same or pretty close levels from the input to the output. But all in the middle there, that's where all the magic happens, right? So we should get this oscillator on top of a guitar or a vocal, and it should give us funky sound. So I'm looking forward to seeing it. And so right now you're looking at the board. So it's a small board. It's nothing that extravagant. So I'm going to get on to building that. So let me do that. Let me put you down, and then I'll bring you back in on the parts list. Okay, you can see I've got the PC board done already. I did that along with two other boards. I like to do batches. So instead of boring you with the whole printed circuit board etching and everything, I just figured I'd do it ahead of time. So I've got it drilled. Traces look fantastic on this board. I'm using the blue transfer paper. Works wonderful. And also you can see the parts. I did not have to buy any parts whatsoever. I had them all. So that's very convenient. Anyway, let's get these parts onto the board, and I'll bring you back in. Okay, good news, it's done. As you can see, all of the potentiometers and the switches and the input RCA jacks are connected to the board. Of course, I've got the potentiometers reversed. You know, I would never get that right? Anyway, so I'm going to have to reverse those later on. And yeah, so I've got a signal generator connected to the input, and the output of the sound bender goes to this guitar practice amp, right? I built that not too long ago, and that's connected to the speaker. And yeah, so let me turn it on, and I'll throw a signal onto it. Right now I'm at 400 hertz, and the output is about 100 millivolts RMS, or the input's 100 millivolts RMS. Let's give it a try and see, or let's hear it. All right, so this is the input volume. This pot here is the frequency. It's almost like a tremolo. Like, it's really crazy here. And this one is null. I'm not too sure exactly what that does. It does make a bit of a difference. And this pot here is, I think, well, this is the mixer. So both the original signal and the oscillator from the XR2206, they go into these two pots here. It's actually a dual ganged pot. And this one is for sine or triangle. I'm thinking that's triangle. I think that's sine. And that's about it. Let me just vary the frequency. Okay, so let me hook up a guitar to this thing, see how that sounds. Okay, I'll bring you back in shortly. Okay, so I've got a guitar hooked up to it, and clearly I can't even play the guitar, so I'm not going to pretend that I can, but it does give some weird effects for the guitar player. Yeah, let me just pluck the strings. Okay, I think you get the point. All right, you know what? Let's hook up an oscilloscope to this, and let's take a look at some of the signals. Okay, so here is the setup. I've got my homemade function generator as the input to the sound bender, and the sound bender then goes to my homemade guitar practice amplifier, and the output of the practice amplifier goes to an 8-ohm load. I didn't want you to listen to all that crappy noise. Anyway, I've got a power supply here. That's the homemade power supply. So yeah, everything is homemade on this particular circuit or setup. Anyway, let me just focus in on the oscilloscope. Now I have to bring the camera in a little bit. It's the best I can do. This camera will not let me zoom in while it's actually taping. So anyway, I've got it set to where the frequency is high. So, and that'll demonstrate the kind of modulation that this circuit is providing. So that's our input signal, and that's our output signal, right? And if you actually follow the sine wave, the input signal, you can kind of see the outline of it there. And that means the actual input signal is carried upon that actual oscillator frequency. And that's actually coming out of the XR2206. Let me just adjust that frequency, and you can see how it changes a lot. So I'm lowering it. And I think if we brought it out a little bit, you can still kind of see that same modulation there. What else can I show you? Let me increase that frequency again. The output control just controls the gain. And here's the null. I noticed a big change on the null potentiometer. We couldn't hear it before. I could hear a little bit of change, but not a lot. And what else? Let's see. Oh, and here's the input control. So that's the actual volume, or the input volume. Oh, here's what I wanted to show you. I wanted to show you the right now it's set for sine as the carrier, if you want to call it that. And this is triangle. And you can clearly see a big change. The actual input signal isn't so pronounced on the actual triangle wave, but it does give a different sound. I'll go back to sine. Anyway, I'm just adjusting some stuff here. All right. What more can I say? Yeah, I mean, I think that just demonstrates the sound better perfectly. Anyway, I think at this point, what I want to do is I want to put the actual sound bed in a box. So let me get started on that and I'll bring you back in. Okay, so it's done. As you can see, I've got the board in the case, and yes, I'm using 8 AA cells. That gives us the 12 volts. I thought it was 4 at first, but anyway, 12 it is. Yeah, so I mean, it worked out pretty good. I mean, not much to really say. It's kind of organized, better than usual. Yeah, I'll just show you the face here. You can kind of see that better. Yeah, so, you know, I've got the input volume, the null beside it, and the sine or oscillator, or sorry, the sine or the triangle oscillation, and the frequency on top in the middle, and then the output volume to the bottom rightish, and the power switch, and of course the inputs and outputs at the very top. So yeah, I'm kind of pleased, you know, to the way it looks, and let's give it a try. Okay, so let's give it a try. Okay, so it works. It's another successful project. Yeah, I get it. It's probably not that useful, but you know what? It's another project, another learning experience. And that's, you know, why I like doing projects, because I learn a lot too. Before I showed you the actual inputs and outputs, so now I understand, you know, how something like this works. Yeah, I had a good time. I had a fun time building it, actually. It wasn't that difficult either. So I hope you liked it too. And yeah, so it's another project from a magazine. You know, they're not always the greatest, but you know, this thing works, so I'm happy. Anyway, let's end the video here. Thank you for watching. I really appreciate it. Again, please like or subscribe. I'm not close to being monetized yet, but I'm working on my way getting there. And even when I am monetized, it's not going to be a lot of money. I'm going to tell you that right off the bat. It maybe would be like 50 bucks or 100 bucks a month if I'm lucky. So, but every little bit helps. Anyway, I'm not in it for the money. I'm actually in it just to have some fun. Thanks for watching. Check out some of my other videos. I really appreciate it. Take care, and check out the next project coming up soon. Bye for now.